I think the fundamental piece that is not explained here, and I think probably needs a video explainer because I don't think text can explain it, although I would love to hear your suggestions on explaining this in text. There's several notes that I took while you were doing this, things that I could rename. There's, of course, the typos. That's confusing. So there's probably 3 core principles here that need to be understood before you begin at all. The first principle is that a wallet, in the sense of a user's perspective, so me as an individual, not as a developer, a wallet is the 12 words. That is what a wallet is. That is the thing that I have to keep safe. That is what holds all of my money. It's the 12 words.
So the mnemonic, yes?
The passphrase. I cannot use the word mnemonic because that will never get across to an average person.
But you used it.
Only with the word passphrase. I never use that word by itself because no one knows what that word means, and it's actually being used incorrectly because mnemonic means something that you remember.
Yeah.
And nobody can remember 12 words, especially not 12 random words.
Oh no, look right here.
Can remember 12 words. Oh, that's because that's the literal quote. The literal quote is mnemonic for generating hierarchical deterministic keys. That is literally the title of the white paper.
Okay.
So yes, I only use it in combination with the word passphrase. The documentation on these things is not consistent in of itself with the use of different terms like passphrase, password, secret, and salt. They all get used interchangeably and in the wrong context. And in contradiction to context that anyone outside of the cryptocurrency space who is into cryptography would already understand. So when you get down to the lower levels, the usage of these words is nonsensical, in that they started using words and then they just repurposed them as needed willy-nilly. And it's in these white papers, and so there's nothing you can do about it. But in terms of we have to interface with people, when was the last time you opened up a cryptocurrency wallet and it said the word mnemonic? Probably never.
I've seen it. I guess I can't tell you when or where, but I have seen it probably in the last year several times.
But if you use Edge Wallet, if you use the Dash Wallet, it's going to say, this is your wallet passphrase or whatever it says. Let me go into the Dash Wallet right now, just to see.
Yeah,
but no, the point is, mnemonic is a highly technical word that is being used incorrectly. So it's not useful to people who are technical outside of the cryptocurrency space, and it's not useful to the people that will be merchants and users of the applications. So, let me see. If I go to security, view passphrase, it is literally called recovery phrase. That's another thing. It is called recovery phrase. It's called passphrase and recovery phrase in the Dash wallet. Now, here's where it gets weird. The BIP44 actually refers to the salt as the passphrase. So every user-facing wallet calls it a passphrase or recovery phrase or something like that. Yeah, and then I'm actually going to update this right now to make sure that I include recovery phrase. And I think that recovery phrase might even be better. I could substitute everywhere it says passphrase here. I could substitute that with recovery phrase, and I would actually like that more. So that's something that I will consider because that's what's used in the official wallet right now. And I'll check and see what's in Edge Wallet. I think Edge Wallet just calls it a passphrase. I don't remember. But the recovery phrase is in fact the wallet. That is where all the money is. It is not in software. It is literally in those 12 words. All of the money is in those 12 words. Now, in order to find the money, you have to do a series of hashes. But let me not get to that yet. Let me just click. Oh, I'm just going to check an Edge wallet real quick to see if I can figure out. I probably can't figure out where my phrase is. Let's see. Master private key. Okay. In Edge wallet, it calls it a master private key. It looks like.
Mm-hmm.
So, and that one's not user friendly. Recovery phrase is super user friendly. Mnemonic is the worst possible way to refer to it because it has its negative meaning. It's confusing. Other than the fact if the only place you'd ever encountered any of this was in cryptocurrency and you had no other context whatsoever, then I guess it doesn't matter. And especially if you don't care that the word's highly technical, but recovery phrase is the way to go. Okay, so just 1 second while I make a note here.
I mean, I am thinking everything I'm checking right now is also calling it a recovery phrase.
Yeah, okay, so I think I may change the name to be recovery phrase and then in a few places reference it as mnemonic. So I'm just going to make a note of that because I love that. That solves my problem in 100 different ways. It is the best possible way to call it. So I'm 100% in on, and then that removes the ambiguity because if you go looking in documentation refers to passphrases 3 separate things that are used interchangeably but completely wrong. Well, not completely wrong, but wrong. In the PBKDF2 standard, there is the passphrase and there is the salt. In the BIP44 standard, it refers to both the salt and the passphrase as the passphrase. And then it also refers to the word list as the passphrase. So that's confusing. So if you were to say, I need to use the passphrase with the passphrase to produce the passphrase, what? Okay, that aside.
In the same way I was getting confused by some of the stuff, it would be just as confusing because yeah, you're like, I need to use the passphrase to decode or whatever the pass. Yeah, I get that. All right.
Yeah. So the way that I'm going to solve that one problem, and I'll have you review this PR when I make it. But I'm actually going to break it into a step 1 and a step 2. And step 1 is do either this or that, and step 2 is export it. So because it is valid that you can get an X key from an X priv. And okay, let's put that aside though. That's so number one issue, number one most important thing. The 12 words are the wallet. The money is in the 12 words. The 12 words are put together and they are essentially, to put it simply, they're hashed. Not encrypted, not hashed. Unrecoverable, I mean, not unrecoverable, because it is deterministic, so it is recoverable, but it is a non-reversible hash.
Okay.
Every single step, there's 7 steps. Every single step is a non-reversible hash of a previous step. So when we go from the recovery phrase to the seed, that is a non-reversible hash. And that is its own standard. That's BIP39. And BIP39 and BIP44 don't really cross paths. Other than that, it's really, really convenient to use BIP39 to generate the data for BIP44. But BIP39, I think, meaning BIP39 meaning the method by which you turn words into entropy that can be used in other software, that's just generally useful. And maybe I should bring it into -HD, but from my perspective, that's just something that's generally useful. If you don't care about, if you don't care 2 licks about cryptocurrency, Dashphrase is a useful tool because it's something that you can physically print out, store in a safe, and you could use it for, you could literally You could use it for your password manager. This is what Brave does. Brave uses BIP39 recovery phrases to sync passwords between computers and devices. So, what, explain that back to me. Tell me what's clear, what's not clear.
Oh, everything is not clear. It's so
just
much
this part.
information.
Just this part. Just
The
that one thing.
39 stuff is used by Brave to store passphrases.
No. The thing I said that was most important, the only thing we're actually talking about, none of the side notes, none of the tangents. The one
All right,
thing that's
then
important,
I've already forgot. I cannot tell you. It got lost in the side notes. So tell me again.
The 12 words. The 12
Okay,
words
the 12
are the
words.
wallet.
Okay,
the
the
12
12 words are
words-
the wallet.
The 12 words are used to create a non-reversible hash that is called the seed. That is
Okay.
number one.
Okay.
That's the most important thing. Anybody who's doing anything with cryptocurrency, that's the first thing that they have to understand.
Okay.
Without any exception or ambiguity, this has got to be 100% understood. The 12 words are hashed to produce a seed.
12 words are hashed to produce a seed. They're the most important thing in cryptocurrency that anyone needs to understand.
Okay, are you asleep?
No?
Okay.
Did I not just repeat more or less what you said?
Yes. Yeah, but I meant... Okay, never mind. Okay, so with the 12 words, what questions do you have?
So if my questions fall back to CrowdNode UI, and this is what I was trying to get an answer to, and I don't think
Not
you
about
did
that.
answer
About
this.
the 12 words.
About the 12 words, I don't think I have a question about that, because that's something I'm already familiar with, having dealt with cryptocurrencies for many years.
Okay.
So I'm familiar with the idea of a recovery phrase or mnemonic or whatever you want to call it. I'm already familiar with that.
Okay, so that's
so-
number one.
Yeah.
Okay, so this is number two. This is first a subnote, a preface to number two, before I get to number two. There are many different types of hashes because all these white papers were developed independently, and some of them use prior art that already existed in the cryptography space. So I am going to say non-recoverable hash, but each time I say that, it could be a wildly different implementation of that hash, because there are at least, I think, 4 different distinct hashes. More than that, probably. I feel pretty safe saying 6 distinct different hashes that are used between the time that you have your recovery phrase and you get an address.
You said there's 6 different hashes?
It doesn't matter what the number is.
Okay.
I'm just saying that don't think that when I say that a hash is used to do X to Y and Y to Z and Z to A, don't assume that any of those hashes are the same.
Okay.
That's all I'm saying, is that there are a multitude of hash algorithms. It doesn't matter how many they are, doesn't matter how they're implemented. It just matters that you understand that just because I say it's hashed for short doesn't mean that one hash is the same as the other in terms of its implementation details.
Okay.
Because if you were to think that there's a consistent use of hashing algorithms across the different standards, then that could lead you into, that could just lead you to confusion. So you just need to understand that they are several separate hashing algorithms with different parameters, but the details of that don't matter in the sense of when you're using the code. As long as you have the right input and you get the right output at the end, it worked. If you needed to re-implement something in another language, then we could go into those details. But
Okay.
but it's I guess this is a preface to number 2, is that there are a variety of different hashing algorithms. It's not important to know which one is which. It's just important to know that they're not all the same. Okay, so that out of the way. Number 2 is that when you create an extended key, what you're doing is you're taking some prior data that starts with the seed. That's why it's called the seed. You're taking some prior data and you're performing a hash on it along with an index. And the path tells you the information of what depth and what index you're hashing. So M, I don't remember why it's called M. Oh, it's called M for mnemonic. That's why it's called M. Even though it's not the mnemonic, because it's the seed.
Mm-hmm.
So even there's incongruity. M is not the mnemonic, even though it stands for mnemonic. It's the seed. The seed is not decodable to the mnemonic. M is the seed. So it is based on the seed. So at level M is your wallet that has been hashed from the seed. That's depth 0. So it is not the seed itself, but it is a hash of the seed. And it has been converted into a private key, an elliptic curve private key. Every single one of the paths is a private key. So anytime you want to get to a specific address, the addresses start 0 and go to 1 billion. Well, 4 billion actually, and some change. But anytime you want to access an address, you need to do a hash from the mnemonic to the seed, and then the seed to the wallet. Those are the 2 hashes that happen before in order to get to depth 0. Once you're at depth 0, then you need to do a hash to the purpose, a hash to the coin, a hash to the account, and that is essentially what we generally think of as the wallet is the account key. Because when you're in Dash, you don't care about Bitcoin and you don't care about all these other things. You're just looking at it from the perspective of Dash. Mm-hmm. And so the wallet is the account. Is this the primary account or is this a secondary account? Now the account, actually, I'm not going to get into that yet. I'm going to try to stay on number 2. So number 2 is just that this series of hashes happens, and to get to any key, the address that is spendable or can receive money or spend money, you have to do a series of 5 hashes by the index. So the M doesn't have an index because it is the root. It is derived from the seed, but everything else has an index. So the purpose has the index 44 for BIP 44. The coin has the index of 5 because that is what's in the Wikipedia page, or the wiki page, for Dash. And then the account is selectable, but generally it's 0. It's 0 in almost every single application you'll ever touch. Dash is going to be actually Dash is going to be one of the only cryptocurrencies that actually uses accounts.
Okay.
And then after the account is the use. And the use is whether you're using it as a address that you share with others or whether it's internal. So the address that you share with others is your receiving address. You give out an address so that you can receive money. Mm-hmm. The internal address is also called the change address because it's when your wallet gives money back to itself as change. Mm-hmm. But that's not actually part of the important part. That's just a side note because it is what that part is. And then the very last one, and that one, well, I'll get to that in a second. And then the very last one is the address. So It has to hash, 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 hash. When you give it the path, it's just doing a loop, and it's doing all of those hashes at once.
Mhm.
Well, in turn. It's doing all of the hashes in turn.
Mhm.
But if you're going to generate many keys, if you need to walk keys, then you start at 0 and then you walk up 1, 2, 3, 4, 5, and so on. You would walk keys from the prior path, which is the extended key. The extended key produces the keys you actually use. So I'm going to try to say that succinctly one more time. Number 2, the second most important thing is that those 12 words, the seed that they produce, is hashed to create the root of the wallet, and that root wallet is hashed in a loop that goes to a depth of 5 in order to produce the key that you can use. Those indexes, that is called the HD path. So whatever the indexes were to get to the address that you can use, that's the HD path. So number 2 is the HD path. That's the second most important thing.
Okay.
What questions do you have about the HD path? It might help if you brought that back up so you can kind of take a look at it, to kind of see it in context. Right where you were actually was great, but pick whatever you want. Pick whatever you want.
I guess I was going to scroll to where there were more examples. Okay, you keep referencing that hashes are run multiple times for each stage, more or less.
One time per stage.
One time per stage, okay.
So the hash is run on the seed to produce the M level, depth 0. Well, I shouldn't say the hash, a hash, because it's actually different. Then a hash is run on the 44 to produce depth 1. The hash is run on 5 to produce depth 2. The hash is run on the account, which is selectable. So you could have 20 different accounts that could represent, for example, contacts in your contacts list. And then it's run on the depth 4, which is the use, otherwise known as the extended key. These are semantically two separate things, but physically they're the same thing. And then there is the address key, which is depth 5. Okay. So the hash is run at each, a hash is run at each level.
Okay. So what is, how do I phrase this question?
It's hard.
Yeah.
But I that's why I want to have this conversation, because this is hard.
Yeah. I guess what I'm trying to wrap my head around is you've got these. This string looks so simple to me, but also I don't understand what they represent. You just described it, so I understand that technically stands for mnemonic, but it's really the root path. This is what all dash, what is it?
That's BIP44. It means that it means it's a BIP44 HD path as opposed to another standard that doesn't exist and isn't used path.
Mm-hmm. Well, what's the purpose of the apostrophe there? Do I even need to care about the apostrophe?
You actually do. So that's an excellent question. The apostrophe indicates a parameter to the hash. I don't feel that it's necessary to really go into what that parameter is or what it means. It's called hardened or public. If it has the apostrophe, then it is hardened. And if it does not have the apostrophe, then it is public. this isn't really important for anything that you're going to do other than that when you use the path, it has to be there. Those first 3 depths after M, they must have the tick. Otherwise, you will not get the right key at the end.
Okay.
So, and this is something that I would like to communicate better, because I didn't communicate it at all. It was only implied.
Yeah.
But I could see from your, you going over this, that was not clear and that wasn't good. But the reason for the zoo wrong is that it's easy to remember, and all of my examples are based off of that. Every single key that's in this example is based off of that recovery phrase. And the reason for this is that it is so easy to get something wrong. You miss the apostrophe, you think, oh, I've generated a key. Oops, now you've lost your money. Right? Now, in truth, you would be able to get that money back as long as you executed the same bug, because the key that it will generate is a valid key. No software will know how to get it. So that's why I have the word list here, the recovery phrase here, is that it will help you to know that you use the code correctly. And then you change it and you know everything else is going to be correct. So I'm not arguing the point that should be more clear or anything like that. I'm just saying that I think that as a developer, your first experience with this should be using that phrase. Because if you're not using that phrase and you get a random key, if you made a mistake, you won't know. And then your software won't follow the spec and it will be, people could lose money. Does that make sense where I'm coming from there?
Yes, that makes perfect sense to me. I just it did not make perfect sense when I thought you were telling me, hey, you should just go ahead and implement -HD now while you're on it. And to me, I'm like, well, had I gone to implement this and you not been in the chat, I would have just banged my head against a wall for probably hours going, why isn't this working? Or what? Like, it's working, but it's not generating like new private keys, or like I wasn't sure that should be changed. It seemed like it.
No, I get it. I get it.
That. Yeah,
I get it. No, I'm 100% on board. I think because I used the phrase word list, I think that made it a little bit more difficult rather than calling it recovery phrase. So I'm going to change this in both libraries to be recovery phrase.
Yeah, that would clarify a lot.
That's going to help. So that's going to be on my to-do list for tomorrow. Okay,
Sweet.
but any questions that you have about the HD path?
Not until I use it. Like in reality, I'm sure I'll have more questions, but for me, I don't.
Okay. Your main
still
question that I want to clarify is an HD path unique enough? Yes or no?
Like, it does not seem unique to me from this example, but okay. I don't know. Like,
expand.
I don't. Huh?
Expand. Tell me why this does not. Why do you not think that this is unique?
Well, I think this is where you're saying this HD path is based on this Zuzu thing. Is that correct?
Nope.
It's not.
No, the HD path. So the HD path is literally an index. It is literally a path, like a file system path.
Okay, so then this is why, because I thought I understood it correctly, and I think now I do understand it correctly. This before, or the way I was going to do it is this would be a public key to this WIF. This WIF could potentially have the same HD path as another key, correct?
No.
No.
what? But walk me through your logic. Just take me through that. How could that ever possibly happen?
That's where I really don't know, because the only examples of HD paths are these very short ones, and I don't see like, okay, this is a real one that was generated to or like that we arrived at. Like this just looks like a string to me, like saying I'm
Okay, so I'm going to try to clear up a point of confusion. If you were creating a wallet that had multiple sets of recovery phrases, the HD path would not be unique.
That is what I mean, because I assumed we were generating completely unique wallets in the sense of each one has a different recovery phrase.
Again, wallet is a term that is so incredibly overloaded that it's really difficult to talk about. I don't know what you mean by wallet in that context.
When I say wallet, I mean the WIFs I have been using for CrowdNode were unique to a specific recovery phrase. Now, while I did not have the recovery phrase, I was assuming that was a one-to-one. This WIF connects to this recovery phrase.
So every WIF in your wallet, in the typical case, every WIF in your wallet is a combination of, well, not a combination, is derived from the recovery phrase. So you take the recovery phrase and then you take the HD path, you convert the recovery phrase into a seed, and then you put the seed into the HD algorithm along with the HD path, and you will get back that same WIF. And you increment by the final number. Well, you could increment in multiple ways, but the way that you realistically would increment is by depth 5. So you have your key 1, key 2, well, key 0, key 1, key 2, key 3, key 4, key 5, so on and so forth. So the uniqueness is between the recovery phrase and the HD path. If you have multiple recovery phrases, then your HD paths are not unique unless they are paired with something that ties them to the recovery phrase. Because I would need to know this address, the private key for this address has to be generated from this recovery phrase at this path.
Okay. I guess I don't understand how this has been working right now then, because I have not dealt with any form of recovery phrases this entire time. I've just been
because you are implementing it based on the way that I implemented it, which is the way that the very first, if you do nothing with Dash Core, the desktop application, if you just open up Dash Core, it's so scary. You could lose all your money just like that. If you do not go into the debug console of Dash Core to enable the HD option, it literally just creates random addresses. And you better hope that the backup becomes recoverable. There are forums all over the place of people that have lost money through the Bitcore wallet, which is what Dash Core is. It's called Dash Core because it was Bitcore and they renamed it Dash Core. So this is functioning the same way that the Dash Core desktop thing functions, which is that it just generates a random key, right? Because the fundamental principle of a hash is that you take an input and you get an output that appears to be random, but is in fact deterministic, right?
Okay.
Do you understand what I'm saying? A hash produces deterministic output that appears to be random. Is that 100% clear?
Yes.
So there is no difference between generating a random 32-byte string of bytes, There's no difference in generating 32 random bytes from pure entropy and generating 32 bytes from a hash in terms of the way that the program's going to interpret it. It doesn't know that it came from a hash. It doesn't know that it was cryptographically random. It has no concept of where the bytes came from. It just uses them.
Okay.
So at some point, this is an important piece of information. I don't know what layer it belongs at. Maybe this should be number 2. But a private key is any string of bytes, 32 bytes. Or a private key is any string of 32 bytes that when plotted on the graph doesn't generate an exception. So you generate 32 bytes, you run the elliptic curve to see if those 32 bytes will fit on the curve, yes or no. If they fit on the curve, it's a private key. The output. Not the bytes themselves, but when you run the function, f of x goes to y. If you can produce a y value out of an x and y value, actually, but if you can produce the thing that creates the point on the curve, it's a private key.
Okay. Sorry, I'm trying to take notes of some of this so I can reference it.
Okay. And that was confusing to me at first, and I actually dug through the SecP256K1 library pretty much line by line to reach an understanding, and literally that is it. You run the math, and if it doesn't end up with a divide by 0 or a multiply by infinity, it's a private key. But every once in a while, you will end up with something that after you mod and you multiply and you add, you end up either with a divide by 0 or with a multiply or add infinity. And if that happens, that's an exception. That is not a private key. But that's how you determine if a key is in the key space. Because with RSA, I don't know if you're familiar with RSA.
No, I mean, I vaguely know of RSA from terms of generating keys, but
yeah, well, the way that RSA works is prime numbers.
Mm-hmm.
So you have to find a prime number, and if a number is prime, then it's a private key. That's basically, it's that simple.
Mm-hmm.
And it's that algorithmic. There is no algorithmic approach to ECDSA. You create a random number, and then you check to see if the random number if it throws an exception when you run the math on it. And 999,999,999 times out of a billion. Actually, it's way better than that, but you get the point. It'll generate a public key from the private key. But in that 1 out of a quadrillion time that it doesn't, that's when it's not valid. And that's what I was talking about, is that you can't know if a derivation will succeed because you're essentially generating what for all practical purpose appears to be a random number. Because you take what was randomly generated, you hash it, so now that's in effect random. You hash it again, that's now in effect random. You hash it again, that's now in effect random. You hash it again. Any one of those hashes could be your lottery ticket that fails and crashes your application. It's a 1 in a quadrillion chance, but it happened to somebody at some point. Okay, so taking a step back, another way to say this about the HD path is that the index is essentially the salt, and the apostrophe is a choice of choose this algorithm or that algorithm.
Okay. Okay. It's true or false at the end to tell you which algorithm to use, and you use it 3 times in a row so that it does the HD key. If you didn't use it at either of those times, it would not be an HD key.
Hardened.
Hardened, not okay.
And I heard something that now, having reviewed the code line by line, I don't think is true. Because somebody had told me that well, it doesn't matter what they told me. I don't want to confuse you. It wasn't correct, I don't think. But hardened means that you use the private key as part of the algorithm.
Mm-hmm.
And public means that you use the public key rather than the private key. And this is why I can take a public key and I can give it away to a friend. I can take my extended public key, my XPub, and I could put it in a QR code that somebody could scan, or I could put it over the DashPay network so that somebody could receive it on the other end. And I'm comfortable doing this because the XPub is derived from a public key twice over, essentially. So there's none of my private key information even went into that algorithm at that layer. You'd have to go 2 layers back to get to a private key. So it's very effective in terms of, if my friend compromised everything that there is to compromise about that key, there is no information whatsoever in that key that could ever help them under any known circumstance, now or future, get access to anything else outside of that keychain. Or that, not keychain, but key tree. Does that make sense? Now, from looking...
I think so, yes.
So it's basically the public key is used as part of the salt, essentially. The index and the public key are used to salt what's called the chain code. The chain code is just a 64-byte derivation of a previous hash that then part of that is mixed with either a public key or a private key to then produce. Those things are not really important details for you to be able to use this, but that's the hashing algorithm. It's mixing those things together. That's how it's deterministic. So I think maybe a better example for this would be the example that made it make sense for me that maybe I should have included in here. And it's not something that you need to do. It's just really, really illustrative. Take the HD path and call split on slash. Now, for every, and this is what the derived path function actually does. It's literally what it does. It takes the HD path, it splits on slash, and then it takes the first one, uses that as salt, and creates the next key in the chain. It takes that key, takes the next index, uses the next index as salt with that prior key, and then creates the next key in the chain, so on and so forth, until it reaches the end. So what questions?
It splits by slash and then takes each of those values and uses it as the salt.
Part of the salt, yeah.
Part of the salt, okay. I guess what I still am having trouble wrapping my head around about the HD key is I feel like I need more examples of what it looks like in actual usage, because at least
So
in
go to the loop. Go to the loop where I said a batch of 20 keys. Just search the word batch.
not this area then.
There you go, right there. Derive a batch. And look at where the HD path is created right there.
So you've got account index, and you've got use, and you've got I.
Yep. And you see what it's doing there? Keys.push.
Yes. Oh, I didn't want that to jump that far. Where'd it go? So you've got keys.push, you're pushing the HD path, the address, and the width. I think this is still what I'm having trouble with, is you're saying this would be unique, but I guess I'm wondering if you've got two different recovery phrases in the sense where...
So no, it is not. It is only unique per recovery phrase. It is
Okay.
not unique across recovery phrases.
And that's why I would prefer not to use it for the key, because I would prefer something that's unique per recovery phrase. So that you're never
the way
going to
that
have
you
a
would
collision
get
there.
that. So here's the thing: you don't have an option. You have to use the HD path. That said, you could fingerprint the recovery phrase, and you could combine the fingerprint of the recovery phrase with the HD path, so that you could say, so instead of M, because M is actually ignored. Well, it's not ignored. It's expected to be M, but it's useless. So you could create an HD path that is ABCDEF /44/5/ that would be your bespoke way of handling it for your application. And then when you pulled that back out, you'd need to replace that ABCDF with M so that it will work, because the algorithm or the process, the function expects the letter M to be the letter that's used there.
So is this more efficient doing it this way with the HD path rather than just using the public address like you're using in the command line?
Okay, say that one more time.
Right now, I am trying to match this so that it will very closely match what is stored in your file system if you're using the command line utility for this. So, are you going to switch the command line so that it's storing things by the HD path?
100%, yes. But what I will probably do, this needs to be dual indexed, because you actually need to get to it from two different ways. You do need to be able to get from the address, because you need to be able to use the address to look up the HD path and the recovery phrase that was used, so that you can generate the private key.
Okay.
That makes sense, right?
Yes,
or no?
I think so.
Okay. So storing it by the HD path, it's good to know which indexes have been used. So you don't necessarily even have to store it by the HD path per se, but it is a convenient serialization, but you need to be able to know what things have been used so that you can quickly walk and say, okay, I need to generate the next key. Let me walk through the first 100 keys and see if all of them have already been used. Have I already saved them? And if you've already saved them, then you need to keep walking. So you could have something that's, last HD path, and then you start with that last index, which is exactly what I'm showing here in that example you still have up on your screen. Is that you would get your previous index. Somehow you've stored what your previous index is, and you want to continue from the previous index and generate the next 20 keys.
Okay, so let me back up, sidetrack something.
Yep.
But do I need this for the CrowdNode UI?
I don't know exactly what you're doing with it, and need is a strong word. You can continue to just use randomly generated keys. I would not want that to go into production, because it just like the one that I've created for the command line, I want to switch it over to HD keys because that is a much more secure method of generating the keys.
Okay.
But if you need to have multiple keys, which is what we do in the command line, then yes, you need to generate.
But the multiple keys are, as far as I'm understanding, they would be attached to different recovery phrases.
No, I would not do that.
How is the command line not doing that then?
Because you would just have one recovery phrase, and then you would generate.
Does the command line currently do that where it only has one recovery phrase?
The command line does not use HD keys right now.
Okay, so the command line is not doing this in any fashion, but currently it is. They would be essentially unique recovery phrases.
No.
Okay.
I don't know what you mean by recovery phrase. A recovery phrase is only in context of an HD wallet. A recovery phrase doesn't have any other context I'm aware of.
So CrowdNode is not an HD wallet right now for how it's storing things. The command line.
Correct. It is not. It is just generating random bytes and then passing it into the public key, to public key, and if to public key succeeds, then it's good enough.
So recovery phrase literally only applies to HD wallets. Did I hear that right?
Yeah, because that's how HD is hierarchical deterministic. So you use a recovery phrase to create a seed so that you can hash it and use that hash as a private key.
Okay. You're saying that like it's obvious, but this is not information I knew. I didn't know. Like, as far as I was aware, there was a recovery phrase for these things. We just weren't doing it that way. We were using these whiffs instead, type of thing. So I didn't understand that we could never use a recovery phrase for how it's being done right now. Is that correct?
Yes.
Because they're not hardened.
No, because they're random.
Because they're random.
Okay, so there's a missing piece of information here, and I'm not quite. I know what the missing piece of information is. I'm not quite sure how to explain it. To create a private key. Well, let's first start at this. A private key and a whiff are synonymous in the same way that hex and binary are synonymous. Does that make sense? Like, there's no difference between hex and binary. It's just a different, whether I store data in hex or I store the data in binary, the data is exactly the same data. The data itself.
Okay.
Hex is an encoding format. Bytes are an encoding format. Base 64 is an encoding format. But those are representations of data. Whiff is an encoding format known as base 58 check. Base 58 as in base 64, base 58. Check as in checksum. So it's base 58 encoded. The encoded value is used to generate a hash. The first few bytes of that hash are appended to the value and used as a checksum. So that way we know that if I copied, because the idea, if you remember, was, oh, you're going to write down all of your Bitcoin keys and then you're going to enter them back into the computer. And so base 58 was based on the idea that people are going to make mistakes. B's and sixes look the same. Let's pick one or the other, but not both. Zeros and O's look the same. Let's pick one or the other, but not both. That's why it's base 58, is because it's eliminating similar looking characters. And then the checksum is so that if you still manage to interpret a 4 as an H, the checksum is going to fail.
Okay.
And so base 58 check is like base 64, except it's got a reduced character set, and it has additional data that's appended to the data to be able to verify that the data was transferred correctly. And that's what a WIF is. A WIF is one-to-one, no modification whatsoever. Private key is bytes. WIF is the base 58 encoding with the checksum appended. No difference in data, no transformation, 100% recoverable, 100% convertible, back and forth.
Okay.
Did that fill in a missing piece?
Almost-ish, maybe. I think I'm starting to grasp it a little more, but it's still just a lot of freaking information that I haven't, I'm a hands-on learner. I need to connect this to something real that I've already dealt with, and it's still too nebulous for me.
So you've got WIFs right there.
Yes. And that's why I'm trying to draw this correlation. And so I had made this correlation that was apparently wrong, thinking WIFs are the same thing or equivalent to a recovery phrase. And if I wanted, I could get a recovery phrase from this WIF type of thing. But apparently that's not the case. And so I'm wrapping my head around
communicating.
Yeah.
Now we're communicating. Okay. So, to that end, no, that is not how it is done. With that said, you could implement it that way because a recovery phrase gives you more than enough bytes to be able to create a private key. So no, that's not how it's done.
Gives you more than enough bytes to give you a private key.
Right, because a private key is simply 32 bytes.
Okay.
Take any 32 bytes. That is a private key unless when you call the toPublicKey function, it fails because of a divide by zero, a add or multiply by infinity, or other mathematical impossibility error.
Okay.
So you could take a text file, you could take a recovery phrase, you could take a seed from a recovery phrase, you could take a screenshot. You take any 32 bytes you want. Take any file, take anything you want, take 32 bytes from it, take it from a random number, take it from take it from an audio recording, doesn't matter. Take 32 bytes, call toPublicKey on those 32 bytes. If it throws an exception, it's not a private key. Otherwise, it's a private key.
Okay.
And
I guess.
Go ahead.
You're still using this in a new way that I wasn't connecting. So, to me, I guess I thought that Well, there's the like to whiff function, correct? You can get a whiff from what to whiff, right? Yeah, right there. So
Yeah,
while there's a to whiff, I assumed there was like a to mnemonic or to recovery phrase, basically from the whiff, or you know,
and that's clear to me now, and that's why I was really confused because now what you said before, now it clicks. Now I get where you're coming from. Now what you were saying makes perfect logical sense.
yeah,
100% doesn't sound stupid at all. Sounds 100% reasonable. Where we were having the disconnect is that I uh, I was thinking, wait, what do you mean you're going to get something from a recovery phrase without doing some derivation sequence to get it? Because I had not thought that, and it's perfectly reasonable because I think it ends up being the same size. It's 128 bits. Actually, wait, I guess you actually don't get enough bytes because you only get 128 bits. You need, no, for a private key, you only need 32 bytes. A public key is actually 64 bytes. So a public key, in effect, is a derivation algorithm, funnily enough.
Hmm.
So,
see, I don't even understand that. I don't know why that's funny.
well, a derivation algorithm is basically any time that you put in smaller input and get out bigger output.
Okay.
So the public key ends up having more entropy than the private key, and normally you would think private key strong, big entropy. Yeah. Public key either equal or lesser entropy than private key.
Yes.
But that's not the case. In this case, the private key, because the way that the elliptic curve, and this is an aside, so put this in the not important or just tell me to shut up button. But the private key, when it plots a public key, it has an X and a Y value. And as you might be familiar with, a graph has 4 quadrants. It has an X axis, which is why we call it an X value, has a Y axis, why we call it a Y value. But when there's a curve in a graph, you just imagine the letter C going through a graph that has those 2 axes.
Mm-hmm.
The Y value will be in 2 places rather than in 1 place.
Wait, in what scenario would the Y value be in 2 places?
Anytime you have a curve on a graph.
Okay.
Well, I guess parabolic curves aren't that way, but anytime you have a curve that crosses the Y-axis twice, it's on.
Yeah.
If you draw a circle on a graph,
mm-hmm.
there are always 2 X values and 2 Y values.
Mm-hmm.
So not 2 X values. There are always 2 Y values if you draw a circle on a graph. So if you draw an elliptic curve, it's the same. It's not a circle, but, because if you pick one, I'm just imagining a perfect graph with a perfect circle. And so at 0, the height of the circle is the Y value above, and the depth of the circle is the Y value below. And if we went far enough to the right, we'd eventually encounter the tangent of the circle, at which point there would be only one Y value. But there's only 2 points on the circle where there's only one Y value on the graph, meaning that the circle goes across the line. So that's why we have at some point you'll hear the term compressed key. Mm-hmm. We only ever use compressed keys. At some previous iteration of some white paper, it's really weird because most of the libraries default to uncompressed key, which is just insane because we never use uncompressed keys. And they're dangerous because if you use an uncompressed key, you cannot recover that money. It is gone because the blockchain doesn't know how to use an uncompressed key. But anyway, the point
it would
being,
be like sending it cross cryptocurrencies rather than to the same one.
Yep. Yep, it's similar scenario. So a compressed key is simply, you actually don't need to know the Y value. You only need to know the X value, because if you know the X value, there are two possible Y values. All you need to know is it the top Y value or is it the bottom Y value? And there you only need one bit of information for that, because it's a Boolean. It's true top, false bottom. So a public key is actually 33 bytes long, and a private key is 32 bytes long. An uncompressed public key is 64 bytes long because it has the X value and the specific Y value. A compressed private key, or a compressed public key, has the 32 bytes of the X value, but then only 1 byte that is either signaling it's the top value or it's the bottom value. And that's why it's called a compressed, is because it only includes the information that's necessary, which is what's the X value and which Y value. Not the Y value, which Y value.
Mm-hmm.
So that is mostly auxiliary information. At some point you may encounter it, and knowing that that's something to consider, just having, not remembering the specifics, but just knowing that it's something to consider may prove to be helpful.
Yes. I mean, I think it already is. Like, you've just given me a lot of information I didn't have, and you helped me to realize I had a flawed assumption I was making about the whiffs to recovery phrases and stuff. So there's like, okay, that's actually an important distinction that, you know, I was just, you know, oh yeah, it's no big deal. I'm just making whiffs. Like, we can, you know, print out recovery phrases for these people eventually. Like, I'll get that in the app. And it's like, oh wait, if anyone actually uses this with these whiffs, there ain't no recovery phrases. It's just the whiffs you'll be able to use to do stuff.
Yeah, and the point of a recovery phrase is that it is one phrase that encompasses many entities. I say entity because I was about to say wallet, but that term is so ambiguous that it is difficult to pinpoint what wallet, which semantic use of wallet are we talking about. But so I could distinguish by saying a wallet key versus an account key versus a coin key versus a use key, which we call an extended key. And I forgot to mention purpose key, and so on and so forth.
How many freaking keys? We need to drop the word key.
Well, I think that
And
it's actually
wallet.
it's actually important to call it a. It's important to call it a key because that helps you to understand that. So a wallet, as I've defined it in that documentation, is actually not a different structure from an account or an extended key or an address key. They are all just a key. And the only difference is that I put a function on them that is appropriate for their depth so that you don't accidentally use the wrong one. It is impossible with my library to accidentally use a key at the wrong depth. Well, that's not entirely true.
Challenge accepted.
If you use the derive path or derive child, it's open season. Those are there primarily for debugging. Well, derive path is there primarily for convenience because sometimes you literally just want to derive one key and you don't care about the life cycle of your application. But and if you're only generating a key now and then, derive path is great. If you need to be able to quickly iterate over thousands of keys, derive path is not your friend.
In what scenario would you need to iterate over thousands of keys?
Well, let's say that you have a wallet that you've been using for 2 years.
Mm-hmm.
You need to be able to quickly iterate over thousands of keys in at a moment's notice to be able to retrieve information about a specific key. Has this been spent or not?
Mm-hmm.
You know, you might want to click the re-index button. You think that maybe there was some network funkiness and you missed some WebSocket broadcasts or whatever, and you want to re-index. Get the list of all the keys, check them against all the data that you have locally, see if any timestamps don't match. So, 5 times slower is not that big of a deal. It's, it'll take 3 to 10 seconds instead of half a second to 2 seconds.
Mm-hmm.
But, it's nice.
Okay, so then back to what I was trying to figure out, and maybe this is just my own personal preference, but I would prefer to have the option of generating a new wallet in the sense of a unique recovery phrase and managing that. So if you've got a CrowdNode account for one recovery phrase wallet, you can create a new account and still use that all through the same thing. And perhaps it's over siloing, but some of what I'm basing this on is comments you yourself have made, where like if you can track funds back eventually, given you're determined enough or have the right software, like you might want that whatever funds go into this one, it's unique and it's staying there, and it's not like, well, yeah, I used a different public address, but it's all technically in the same recovery phrase private wallet type of thing. Did I make that make sense, or was that too all over the place? So like I would prefer to make this in a way where you could create multiple recovery phrase type wallets and still use them in the way I was thinking that the WIFs were already working.
Yes. So, and this is, the Edge wallet does allow this. And I think that it's a tough one. There's a lot of things that can be done that have never been done that are going to be possible in Dash. So there are some good ideas that Dash platform has, and there might even arise some good implementations to carry them.
Mm-hmm.
The idea of actually making use of an HD path in a practical way is something I don't think anyone else is doing.
Mm-hmm.
Because it's essentially, they always use account 0, and they don't really have a sense of privacy, or it's just, there's an opportunity here, but how we go about it is there's a lot of implementation specific details where we're blazing a new path, and there's not really any predecessor to show us a pattern that's good. BIP44, I think, is an amazing standard that is basically ignored.
Mm-hmm.
Because cryptocurrencies are predominantly used for scams and money laundering, and the people who are implementing things are backed by VCs and all that. They're not based on people that actually want a practical monetary system. BIP44, in my opinion, is designed by people who wanted a practical monetary system.
Mm-hmm.
So to wind that back, I don't think for this implementation that it makes sense to have multiple recovery phrases. I think that there's some higher order choices that need to be discovered, and I don't think that this is the right place to discover them. That said, I'm not your boss, you know. I'm not in charge of this project. It's 100% you're the man to make those decisions. But I personally don't think that this is the right project to explore that. I think that the wallet project is where you, I, and Nick and Ryan all come together and explore that.
I guess while I have not been working on the wallet, I have been thinking that a lot of this work would eventually either be copied over, or maybe not a lot of it, but some of the figuring out of the practical use case of using this in a UI and getting this functionality, because it does have the, you've got to be able to send Dash to it, and you've got to be able to send Dash out of it. And so there are a lot of the aspects that you would expect in a wallet in the first place. So I was assuming a lot of this work will eventually be, this isn't exactly what we want for the wallet, but we can actually copy this, and this, and we've got a good basis and hit the ground running for the wallet. So that was more my thinking, is it's like, because I've said from the get-go, I would love to have an actually full-fledged wallet with something like CrowdNode, built in, where it's not exactly built in, but you could easily I've got 50 Dash. Let me just put that in CrowdNode because I don't need to spend it for 6 months.
So I would, from the perspective of making this code reusable for a wallet, I don't think this code is going to grow into the wallet. I think the opposite approach is what's going to happen, is that this needs to be, from my perspective, this needs to be a demonstrable product. I am heavily interested in people being able to see this and use it sooner rather than later.
Mm-hmm.
From that perspective of this being a component that could be used rather than something that is using, the approach that you already have is actually pretty decent, because you just take the storage mechanism and you say, this component, and I'm using the word component not in the view sense, but in the architecture sense, this component receives a storage mechanism that has keys in it. And this component doesn't care what abstraction composed those keys, whether it was hierarchical or whether it's a grouping, because I could have 3 different hierarchical wallets, and I could say, from this account in this wallet, and from this account in this wallet, and from this account in this wallet, I want to take this key and this key and this key and this key, and these I'm tagging these as CrowdNode keys. So the wallet now knows, don't spend these and don't use them for anything else. They're dedicated as CrowdNode keys. And the CrowdNode component receives a storage mechanism that has access to these keys, and it doesn't know that they came from 3 different wallets.
Mm-hmm.
That's from a practical perspective of, can we get something that we can ship that has a pattern that we can reuse later? From the perspective of, I think that we will all benefit if you can level up as close to me as possible in terms of understanding the fundamental structures of how all of this crap happens. And I use the term crap affectionately, but to mean there's a lot of stuff that's hard and heavy going on.
Yeah.
I think that whatever path you take that gives you that knowledge will probably eclipse this app, because I've kind of accepted that due to circumstances and changes in direction in other organizations, sub-organizations, or co-ops, or whatever you want to call it within Dash, this doesn't feel like a priority anymore.
Mm-hmm.
This felt like an urgent priority, and now to me, I just get the sense of this is old news. It's deprecated. It's not the future.
Meaning CrowdNode UI.
Yeah.
Okay.
And that's not to. I mean, I want this to be done. I want us to have a completed product, but I'm just getting the sense that it's not as important to people as it seemed. That the time kind of passed, and a bunch of things had happened, and other announcements were made, and where this was actually something that I thought there was some sort of sense of people are going to be really excited to receive this. I hope they still are, but it just seems like there's been confusion, because now that there's this taste of, well, there's going to be a CrowdNode trustless system or whatever.
Mm-hmm.
It kind of invalidates what we've done.
Yeah, but they don't have a way of interacting with it without through their UI, which is.
I get that, but I think that I think there may be the same sense of confusion that you and I feel about that. I think the general populace might feel about this.
Mm-hmm.
That because now they've been told multiple things,
Mm-hmm.
no matter what they get, it's not going to make sense to them because it's not going to meet their expectations. That said, I hope that Ryan comments on this and says, AJ, you're so off base. You have no idea what you're talking about. You just haven't been participating in the channels because you're not a participator of channels. And as soon as we can get this out the door, fire and lightning are going to come down from the heavens and you fill the void.
Look, I don't know if there's expectations on this, but I think once I've got it wrapped up into the prettier UI that I'm planning, I think it'll blow people's socks off as something they'll want to use because it is that clean of an experience. It ain't there yet. I thought it would be there, but then we've had several refactors here that I wasn't exactly intending on.
Yeah.
But at the same time, like this encryption stuff, like I can extract that crypto store stuff, separate it from the local storage, and then have it so if you want to use that exact same stuff in Node, you should be able to use the same library. Like I can separate that out, and then that's a solved problem, and we can get both the command line and this using it, and the wallet could potentially also use the same process. I'm assuming.
I don't think I'm going to invest. I'm just thinking of this right now. This is not something that I thought about before. I don't think I'm really going to invest more time into the command line.
Okay.
I think I'm going to invest time into the command line only in as much as it helps towards building a wallet, like the crypto stuff. I will probably do that with the command line.
Mm-hmm.
The crypto as in cryptography, the right way. But I don't think that I have any ambition to make it better because I'm not seeing the vision anymore. I'm not seeing the excitement. I'm not seeing a reward on it other than in dollars. And there are so many other things that I think have more potential to be working on that I'm not seeing myself going back to the CrowdNode CLI to bring it up to snuff with this new set of tooling. Because, well, maybe I could actually, because there is a potential use case of somebody made a remark that it was scary for them to consider using it because of the number of dependencies. That would be the one reason I'd go back to it, is if it feels worth it to attract those sorts of people. But, well, I don't know. I don't know. But I want to look more towards wallet and merchant payments. That's where I think that there's going to be a bigger difference made. And Ryan, if he, comments or has some input on that, great.
I don't disagree with that, but I do think having having an ability to at least invest your money in some form and earn some interest, and keeping it in, like, some reward for keeping it in Dash and not just transferring it out to USD or whatever your local currency, I think that has value. Like, oh yeah, I could put this in my bank, but I'm just going to earn 1%. But if I leave it here, I'll earn 6%, and Dash could go up in price. So even though I only earned this much more Dash, like, I think that is incentive. But I do think it's more incentive, at least from my perspective, where it would be incentive if it was where I was already storing the Dash that I was using.
Yes.
If it was like, and in the same way, like, I can use my Dash, I can stake or invest the Dash, or like I can also interact with merchants in the same way that if you use Dash Direct or something like that, and it makes a request, it hits the Dash wallet on your phone, and it makes a request from that, and it pays out automatically. I think having that kind of stuff all built into one thing is a great idea. Like, I would love if what we were building in was the trustless side of CrowdNode and not just the current implementation. If they got that in an API, I think that would be amazing, because then you've got, well, I'm not signing up for CrowdNode with an email or any other information. It's just connected to my wallet.
And that was my original, for wanting to get into this, was that exactly.
Mm-hmm. Yeah. And so I see the value in that, where it's like, okay, my wallet is just this. Like, it doesn't need any of my identity information. It doesn't need any of this. Like, it is a store of money, and I can invest that money, or I can spend that money, and I can easily spend it if I want, or I can easily invest it if I want, but make that as easy and attractive as possible, I guess. And so I could see that this CrowdNode UI all on its own is not as beneficial as it built into the wallet or integrated in some form with the wallet type of thing, where, yeah, that I'm beating a dead horse at this point. But yeah, I agree with some of your sentiments, but some of them, I guess, I haven't reached the same conclusion you have yet.
Excellent.
Maybe I will, but not yet.
But the other reason that I would be excited for you to pursue the path that you're suggesting, with being able to have multiple recovery phrases and all that, is that it would put the grind on Dash HD. And Dash HD is a betting horse for me. I think that this is, I spent a lot of time on it, and I hope that it is the best HD wallet in the ecosystem. I think that it is. I believe that there is no better JavaScript code than this for an HD wallet, and that there is no better documentation than this for an HD wallet. With its failings, I think that you understood more about HD wallets tonight than I understood in my first 2 weeks.
Yeah, I don't know if I fully understood it, but I have more knowledge that as I run into things, I could go, oh, that's what he meant. Like, connection. Yeah. Okay, now I can move forward. Like, I do.
And there is a glossary too, by the way.
Yeah, I know. I skimmed that.
Yeah, so I am very interested personally in getting feedback and improving the documentation on this. I think that the discovery that we made, that we need to call this a recovery phrase, was a $50,000 discovery. Well, maybe not that high, because it's somewhat obvious because it's being done everywhere. But from the context of, we're working at a lower level, and nothing else at this low level refers to it in a way that is so easy to understand. let's call it a $10,000 discovery. That was an important discovery that we had of what words to use for this. And I am so grateful that you took the time to go through that. And I tried to be more hands off and not answer your questions so directly, so that we could see, have we captured and preserved this knowledge or not?
Yeah.
And we haven't perfectly, but I think that just
there's also
seeing you
the
go through this.
stream. I've got you on the stream. This is being recorded.
Yeah, and I think that we should actually cut a huge section of this and put it on the other channel.
Oh yeah, that would be fine to put it on the Dash Incubator stuff, because I think this conversation, especially after the end, it's helped work through some stuff, and you've explained a lot that, I mean, maybe you've already explained it on your own streams, but in a conversation like this is different from someone's chatting with you on your stream type of thing. So
yes,
yeah.
Yes.
So the other thought, it's not important, but it's the thought I've had is, even if there's no code reuse between CrowdNode UI and whatever the wallet is, the fact that I'm learning how to use the tools you've now built, there will be knowledge transfer that I can take from it. So yes. It might not be like we use any shred of this code, but if I know how to work with Dash HG and Dash Keys and Dash Phrase and can just hit the ground running, building the wallet, that will not be time lost.
Right.
But if we do get some snippets, if I am able to go, okay, this is how I'm working with it. It makes a lot of sense to have this function and these three things together, because whenever you're doing this in a UI, you basically always need these three things. I think there will be some stuff out of that where it will transfer over, even if it's not, we're using all of the UI type of thing. I don't expect us to use all or any of the UI necessarily, but I do think there will be some functionality here that, especially as I clean it up, it'll be like, okay, this is a good solid function that when you're trying to translate this into a user interface, you need something like this.
Yes.
Yeah. All right. Yeah. I don't know. We've had some rants. Good times.
We're had by all. Yeah. Okay, so I'm glad that we cleared up some stuff. Are there any other? Do you want to go through anything right now? Do you want to try anything right now? Do you want? Is there anything else I can assist with right now? And have we really been doing this for 2 hours?
I mean, I'm at 6 hours and 15 minutes on this stream, so
wow.
You've been on probably at least 2 hours, maybe 3. I don't know about this call, but
no, I've been
hour and a half.
I've been actively invested in this for 3 hours.
Yeah, that sounds about right.
Well, anything else?
I mean, not right now. I think I'm ready for a break type of thing.
Yep.
I've got so much information that my mind still needs to process. I was hoping to get to more of the stuff I was planning to, but I did need this information. It's stuff but yeah. I think I need to process that. I wish I had more focus right now to do more of what I was planning, but I don't think I'm going to actually get to that.
Okay.
Yeah, thank you though. Thanks for explaining all of that, and at least worst come to worst, I can always rewatch this last 3 hours to go, okay, what did he say? How did he explain it?
Yeah, well, I think it is fine to have the conversation again, but the important thing to me is that we capture this in text, that the missing bits we get into things that other developers can use without watching a 3-hour stream.
Yep, I agree. Which, I mean, that might just be I think for me, I need to complete more of this and actually use some of what you've described, and then I
Yeah.
can try to compress it down into here are the takeaways from this from a new to it perspective. Like here are some like more AJ perspective, having been in it a while, like in the thick of it. Like I think we can compress it down into a more digestible form for other developers. And yeah, like if we could write that up, or both of us write up our own versions and like interlink them, so we've got good reference material from like both perspectives type of thing. I think that would be great.
Yeah. All right. Well, I'll let you go. I'm gonna keep transcribing some of these notes and making some documentation changes.
Sweet. I might try and do a little bit more coding, but I don't know how much I'll realistically get done. But
Okay.
all right,
Well,
I will catch
I'll
you
hang up,
later.
but I'll stay on stream.
All right, later.